Good morning, everybody, and thank you, Evan, for the wonderful introduction. And we're here to speak about best practices for process improvement in our manufacturing series. And we're going to focus a little bit today on food and beverage companies and recipe management and how that affects production of food products in the manufacturing cycle. Um, Who is CS Worldwide? We are business advisors. We are problem solvers. We work on improving your process. And we understand that change is difficult. And therefore, we not only assess, we help to remediate and implement solutions. So, as part of our group, we have over 45 different professional solution providers that can assist in putting together any solution that we offer as a means towards taking you becoming more efficient and more effective. Our tagline is we marry people, process, and technology to increase or improve clients' productivity, reduce their costs, and essentially increase their profits. Myself, president of CAS, I am a CPA and a CITP, which means I am a certified information technology professional. So we look not only at the way the process works, the controls around the process, which we're going to talk about today, and the automation of the process, and do a little discussion about the difference between a manual process and an automated process and how that works. And of course, documenting a process is real important. And I know Kevin's going to show a little bit of that later in this presentation. Get down to basics. What is a process? A process is just a series of steps performed by a group of stakeholders to achieve their goal. It's a fundamental building block of change management. And again, we say it all the time, change is difficult. So automating a process, documenting a process, and making it efficient and effective is the best way. We work with our clients in making sure that the people who are working the process become part of the solution and are never seen as part of a problem. Properly thought out process is a lifeline of any business. It makes them streamlined, makes everybody responsible and accountable for what they are used for. And then we always say, and again, it's my accounting hat I'll put on right now, information is king, and everything has to get back to the finance and accounting department so they can review and assess situations. And then we use those numbers to show us how well our process is performing. Why do we need a well-defined process? Well, we need it to standardize that set of procedures. We need to identify which tasks what the tasks are and how they affect our overall business goals. We do it to improve efficiencies, either from an individual, a department, or a goal for the entire group. And processes should also be streamlined. Communications between people, function, and department should always be streamlined so people aren't giving different flavors of the truth, different ways of looking at things. Everybody is looking at what the process can do for the company as a whole. And if we have a proper process and we have a set of goals and achievements that need to be made out in that process, who's accountable for that, we prevent chaos from creeping in our day-to-day operations. So that's why we document it. We use that documentation for training, for understanding the process, and for making changes to the process. What are our do's and don'ts related to creating and managing a process? We've streamlined it down to 5. They're listed not in order of importance, but are a good guideline to go by. So our first do is safeguard your assets. Again, we talk about putting those internal controls in, not only with systems, but with people and personnel. Don't expect that only a person, one person, is going to be accountable, put the set of controls in. We'll talk about what type of controls we can put in a little later, but we have detective and preventative controls, which make sure that process doesn't go off track. Make sure your information is flowing properly from one department to the other. Again, this is about information flow and how we do not create silos where one department has information that if they're asked, they'll give to another department, but usually they keep their own set of KPIs and goals, which allow them to see where the process is going. It's important to document your processes, to use them as training manuals. And if everybody's following the same manual, we know we're going to prevent bottlenecks and being able to identify our gaps. One thing we always teach our clients is to avoid using email, Outlook, Google, Gmail as the only means for managing workflow. Being that, I'll copy everybody on an email so they'll know when my part of the process is done, what may be issues with my process. And what this does, again, is it creates a potential for silos or bottlenecks in our process and our productivity. Working with a client now, they use email a lot within their processes. I spoke to the controller, and she said that she had an email box with over 2,800 inbox emails. There's no way you can manage a process or manage your daily workflow when you have to look at that much. Create budgets for each department to ensure all managers are held accountable for their spend. And you should always review your performance as we build processes. We want to make sure that we don't cut corners, eliminate expenses, that we take a targeted approach to ensure that what we're spending is proper and justifiable. And the last thing we talk about, which is a big part of this, is automating a process by integrating software. Wouldn't expect anybody to automate a process until you've laid it out manually so you can understand all the different scenarios that may be bottlenecks or issues. And then you would take that and automate it. Too many times implement software first and then use that software to create our process. What that does is it creates bottlenecks, slowdowns, even shutdowns of processes. What does it mean to automate or control a process? Automating a process requires that the stakeholders understand what it is they're supposed to do, how they're supposed to perform it. And again, as we just said, if we don't sit down and walk through it in a very manual way, there's no way to automate the process. Everybody's process is a little bit different, and you want to make sure that you are counting for everything that happens in that process. You've counted for scenarios if something may go wrong, so you can have a different channels that can be put in, different roads you can go down to correct this. And again, wearing my accounting hat, we always look at proper internal controls in order to avoid errors in processing, which lead to a loss or inaccurate data and maybe even a theft, which we wouldn't want to happen. And therefore, we want to make sure that we have the proper controls, and those controls are both using personnel and using different safeguards within our processes. Two different controls we talk about: a detective control and a preventative control. A detective control is usually considered or referred to as a corrective control. They are designed to detect irregularities, errors that may occur, and provide users with a set of corrective actions in order to remediate that. The simple definition everybody understands of a detective control, whether you do it personally, whether you do it in your business, a bank reconciliation, we do it after the fact. We make sure that the money that we put in and take out of our bank account is properly recorded in the bank. And we do that by doing a bank reconciliation, which is a detective control. A preventative control, on the other hand, are designed to keep errors and irregularities from occurring in the first place. And that's what we want to do when we automate a process. We want to make sure we put in as many preventative controls as we can. So in same scenario, if we were making sure that all our information is entered into a system first, and if that system would then guide us to the next steps, which means if we need certain information to be quantified, then it would quantify it for us. So we're going to talk about this in our process when we have quality control standards and in measuring out for a recipe. And if you can have a tolerance of point something to the right or the left of measurement, that is a preventative control. When we put the the product onto the scale, it's got to come within the tolerance, otherwise we don't move forward. That would be a example of a preventative control. What do we do in order, again, to automate our process? What steps do we follow? First thing we do is build a process map, which I think Evan's going to show you later on how that works. We then review all the areas in the map to make sure that we're only entering things once and then using it or accessing it many times. We don't want to have double entry. Double entry leads to errors. So we want to make sure that we can only enter that information into one part of a system, and then it flows through the system so everybody can use it. We want to make sure have the right amount of controls, both detective or preventative controls, built into the process. We want to identify all the tasks within the process and make sure that when we're capturing data for that process, we're capturing it properly. Want to make sure that the outputs that come out of the system are useful as KPIs that can be used to make sure that the process is working. And we want to test and train on the automated process as much as possible. And we always recommend that we train is our mantra, that we not only train people once, but sometimes it's important to go back and retrain and make sure they understand what are they accountable for. Let's show you a process that we worked out with a client. This is a bakery. They make cannolis, sell them to all grocery stores throughout the country. And in preparing the mixture, they were a very manual process. We were able to automate them and capture that information in their ERP system. The manual process, which we had documented for them first, talked about grabbing the raw ingredients, flour, yeast, sugar, and salt, in order to prepare the cannoli shells. What would happen would be they would need to look at all the orders that were in the system from the night before. They would need to manually go and see how much of each ingredient was needed, calculate that either in Excel or in a rudimentary system, and then create a work order traveler, which would take that raw material from the raw material room and put it into the work in process room. We would send that piece of paper over to the raw material room. They would pick up what they have, writing down on the manual traveler what they used, how many packages, how many pounds, and how many bags. Obviously, they would not do to the exact amount because there's always some that's needed extra, just in case something falls, something gets stepped on, is not right. So they bring enough that everybody, that the people who are working with the product would have enough raw material to work the product. Then the mixers would have to come up and pull up all their batches to create what is going to be, all their orders to create what batches are needed. And then they would start to pull from the raw materials, each of the items, and be told, follow a recipe, a written recipe of what each raw material needs to go into each mixer. They would weigh it, they would write it down on the work order traveler, and they would put all the stuff together into a mixer. Once they were finished mixing the product, they would weigh it again, write it down on the work order traveler, and then return all those travelers to the accounting or production department to record that into a system. Very time consuming. If somebody misses the opportunity to write something down, we miss the opportunity of recording that data in a timely fashion. So what we needed to do is figure out how we could automate that process. And we talk about this being about recipe management because every the way that this customer was set up, all different stores may had a different requirement they needed in the size of packaging, the type of cannoli shell they wanted, and therefore there were various different recipes that fed into a common recipe that was used by the system. By having those various different recipes produced in the system, created in the system, they can then use those various different recipes to tie together and see how many, based on all their orders, how much of each product is necessary. So the first thing we did was create the recipe in the system, give them versions of that recipe. So when the store that was making the order pulled the cannoli shell recipe, they could pull their own recipe or they can pull a common recipe. And then we would know how much of each ingredient we needed to pull. That would be a push of a button. That push of a button would create a automated work order traveler, which now is sent to our material requirement planning system for raw material and printed or displayed on a screen in the raw material room. If it's printed, usually printed with barcodes. So now we can go and scan the barcode on the traveler, scan the barcode on the raw material, and then it would capture what product is being taken from the raw material and gathered for use in the production room. At the end of that process, they would send all the material over to the production room, and it would be scanned in by a stock person who can then, again, using those barcodes, scan what products are being moved over. And that information is captured within the system in a real-time basis, so nobody has to wait till the end to relieve inventory. We would then produce a batch processing, which again, as we talked about, if you took all those different recipes, all those different orders, put them together and went to their lowest common denominator for what is needed to make the cannoli shell, you would find the amount of yeast you need, the amount of salt, the amount of flour, and any other ingredients, and would it set it up for staging. So therefore, if you were to pick the raw material up, preparing it for being put into a mixer, as you used the product, you would add it to the mixer. It would then be recorded of how much product you used in the mixer. The mixer, it has a scale attached to it with those tolerances. So the preventative control now goes into place. I took a 5-pound bag of yeast. I needed 3.8 pounds. As I poured the yeast into the mixer, it's recording the additional weight. It's giving me a tolerance of 1/3 of a pound on each side that I can use. And as long as I'm in that tolerance, it lets me move on. If I'm not in that tolerance, it stops me from moving on. There's the control. At the end, when I say that I've added my mix and I'm able to move on, it now records that I've used this flour, salt, sugar into the mix. And only when all the different products, ingredients are in that mix, would allow us to move forward and finish the process. At the end of the process, just like in the manual, we take any unused product and return it back to the raw material room. Again, in a automated process, we do that by scanning the barcodes on the product and on the traveler, and it shows and it marries it together to say, this traveler now started with 5-pound bag, used 3.8, now it's down to 1.2. 1.2 then gets accepted by the raw material room. Our inventory is up to date and matched. Our work order for producing the mix is up to date and matched. We actually can take it down to the batch level, so we know lots that are used, batches that are used, products that are used, and we can follow this throughout the whole stream of production. Each of these processes should be documented, as we said, as we show, with pictures, with videos, so people can use them, and with instructions. And that's what we've done here. And that's the way you automate a process. Kevin?
Thank you, Dan, for your presentation. Now I would love to demonstrate how you can perform predictive machine maintenance for manufacturing and for food manufacturing operations. Acumatica P3M's platform offers a modular approach, allowing you to choose from a range of features including energy management, visualization alarms, machine health, and more. You can tailor the platform to your specific needs and unlock exceptional efficiency in your manufacturing process. Let's walk through our setup. We have created a few factories, each with their designated areas. And within these areas, we have established several production lines that receive real-time sensor data. This setup is designed to give you a comprehensive understanding of Acumatica P3M's capabilities. Our dashboard empowers you to monitor production with precision. You have the flexibility to create as many dashboards as needed to cater to your specific requirements. Within these dashboards, we have organized several categories. These include OEE, packaging line timeline comparison, packaging line workstation, packaging line classic simple OEE timeline, packaging line OEE overview, packaging line full overview. As you can see, we can also see our work order view, energy usage, and so on. I'm going to go on energy usage more in detail later on. We also have packaging line sub-registration energy, packaging line event registration, packaging line event registration timeline and event logs. And lastly, under OEE, we have packaging line event log. Let's move to the energy. Our energy monitoring setup is key to sustainable manufacturing. We can monitor power consumption and CO2 emissions in real time, identifying opportunities to reduce your carbon footprint and save on cost. Let's move on to the energy production versus standby time. As you can see, we have the energy pie chart. We can see what's running, what's on standby. We can also see how long it's been running for and how long it's been on standby and shut down. We also have the energy consumption packaging line on the right. We can see our CO2 emissions. And we also do graph on below. We can see the power consumption and packaging line. Let's move on to the machine health. Go to factory overview. Here we can maintain peak efficiency with our machine health dashboard. We can monitor the health of your machines to prevent downtime and extend the life of your assets. It's a crucial part of our proactive maintenance strategy. Here we have the health graph. Everything looks good. Below that, we have the anomaly detection. As you can see, some of them are green, some of them are orange. Green means all the machines are in good condition. And orange is we have to make a work order to check on what's going on, and we'll make a schedule under. I'll show you guys how to do that later as well. All right, let's move on to the maintenance. You can see all our work order overview here. So you can see on the left, we have all the work orders are pending. Once you click on it, we'll go on a little bit on detail. You can see start and end dates, and we can see what action they're gonna take while do that in work order. In the middle, we have that work orders that are in progress at the moment. We can see in progress on the status. We can see their names. Lastly, on the right, we have the work orders done in last 3 months. That all done. And let's move to cross analytics. Energy cross analytics. Here we have energy pie chart again, and we can see what's running, what's standby, and what's shut down, as well as with their time as well. Below that, we have the packaging line timeline. Green is if there's any problems. Blue is any gearbox breakdowns. Brown means performance degradation, and so on. And we also have the graph as well. Let's move to the planner. Here, this section allows you to set up production schedules, create products, and manage budget with ease. Its full control is in your hands to optimize your manufacturing schedule, basically. All right, let's move on to the work orders under maintenance. Here, we can see all our work orders. Again, once you click on them, we'll go in more detail. We can see the dates, when it's gonna start, when it's gonna end. We can also see any actions they're gonna perform. If you want to add a new work order, we can always click on add work order. We'll put our name, our description. I can assign an assignees if there's any needed. Let the start time and end time, and action as well. Once we finish all these formations, we'll click submit, and it will show up in here. Lastly, under maintenance, we have the plans. Here we can see all our plans. Let's go open that up. Again, we can see the name, and when it's going to be, we can see the next occurrence as well. If you want to add this current plan to the work order, I can click on add the current work order, and it will show up in our work order dashboard. Additionally, I also like to highlight our sensor customization capabilities. You can create a sensor with names of your choosing, and we have an API feature that allows you to generate data for these sensors. That wraps up our overview of the system. Thank you.